Hey everyone, welcome to another video. We are now moving on to the second half of our series on probability and single variable data analysis. Now, we finished probability, we finished everything there is to do from the Year 9 content, so we're going to jump straight into some statistics and data analysis. Now, since this is a Year 9 topic, I'm working through the Australian syllabus. I'm recording this video assuming you have the basic ideas down for all of the statistics stuff we've done so far. So you understand your mode, median, mean, and range, and as well as just everything else we've talked about with data and the different types of plots, so our stem and leaf plots and things like that. So I want to, in this part of the series, just cover everything that is new to the Year 9 syllabus, everything that's not just a repeat of what we've already talked about previously on this channel. Now, if you need a bit of a refresher, I have plenty of videos on some of this stuff, especially your measures of central tendency, so your mean, median, mode, as well as a lot of other stuff about data and data analysis. But what we are doing here in this video, we are looking at a type of range here. Now, we defined range before as our largest data value minus the smallest value. And we defined these types of this measure for range as a measure of spread. We wanted to see, well, how far does my data span? What is the smallest value? What's the largest value? What's the difference between them? So that difference between them is our range, and range falls under this category in data from our data measurements of a measure of spread. Now, interquartile range, what we're going to be looking at, is also going to be a measure of a different type of spread in the data. Now, let's review everything we know so far about our ranges and some of our other concepts, at least the ones that are relevant to interquartile range. So, if we have an entire sort of data set from this point to this point, and we record all of our values here. We have our smallest value, we have our largest value, and let's look at what we know in terms of rough positioning of these data. We remember right in the middle here, when we write out all of our values from smallest to largest, because remember we always look in ascending order when looking at data, we measured the median. So the median gave us the very middle value, the one that when we have all of our data spread out, smack bang in the middle is what we call our median. Now, when we're looking at interquartile range, have a think of what this part of the word sounds like. Quartile. Now, this to me seems similar to a word we've looked at in maths, and this is a quarter. And to calculate the interquartile range, we're going to talk about that in a moment, but it's all to do with splitting our data into quarters. So our interquartile range, our IQR, is all about splitting our data into quartiles. Into quarters, I should say. So, our median, we could say, splits the data in half. We have one half here, one half here. So, some of the calculations we're doing today, we are going to want to be splitting this, the difference between the smallest value and the median, in half, as well as finding the median and the highest value. Let me just change this to a H. highest value. So I have smallest value. That was an L for largest value. My bad. Largest value. We also want to split this, let's do that in the same color, in half. And we have special names for these particular sections. So for now, we are going to call this guy here. You may notice this is the middle of our lower end of the data. So if this was, for example, the heights of people, of a group of people, this area between the median and the smallest value, that is the lower, we can say that's the lower section of our data. So, and we're going to call this thing the lower quartile. And we call this Q1 for short. Now, this part of our data, our median to our largest value, we can think of that as the upper part, right? Because we're going from the person in the middle right up to the, for example, in this case, the tallest person, if we were looking at data measuring people's heights. So this is going to be the upper end of our data. These are going to be like the taller people, for example. So we call this thing the upper quartile. And we call this Q3 for short. Now, the reason we call that Q3 is because our median, we typically call that Q2 when we look at these types of data. Now, you don't have to think of it as Q1, Q2, Q3. It's just shortened. But all we are thinking about here is our... So let's make a few more points. Our lower quartile is in between, so the middle of our smallest value and our median. And our, so my Q1, my lower quartile, my Q1 is pretty much smack bang in the middle of my smallest value and my median. And my third quartile sits in the middle of my median and largest value. And by doing this thing, by getting a complete midpoint with our median and then splitting the remaining bits here, splitting the lower end of my data into half, gives me 1/4. And splitting the higher bit into a half gives me another quarter. So we have, now, if we look at our data, between here and here is going to be a quarter, or 25% of my data is going to lie here. Another 25% of my data lies here between the lower quartile and the median. Another 25% lies between the median and the upper quartile. And my final 25% lies between the upper quartile and the largest value. So in essence, my data here along this sort of spectrum that I've drawn here, it's split up into 4 equal sections based on the number of people we have. So however many we have, we are splitting the data into different sections. And that's going to be important as we continue looking at statistics in the future. But I'll just leave you with this. Let's jump straight into some questions. Now, we have here the following data values are the results for a school mathematics test. Now, in these particular values, this first question looks at an odd number of data values. Now, you remember, hopefully from before, that whether the amount of values are odd or even, that's going to determine it's determined before how we make calculations about our median, which is very important. And we'll see that it also affects whether we have odd or even numbers in our data set. We're going to see how that affects our interquartile range and our upper and lower quartiles. So for part A here, all we want to do is list the data in order from smallest to largest. That's what we do anyway when we do this. So I have 19, 23, 56, 62, 67, 68, 73, 76. Should have done these smaller. That's okay. Let's do that there. Apologies for the small writing. I have to make do with the space I've been given. So I have 79, 81, 85, 89, and 96. So let's shrink these as well a little bit. And let's make these a bit bigger. Okay. That's about as good as we're going to get it. Now, here, we are looking at, now that this is in order, now we can start to break these bits of data up. So, this first question, well, now that we've done the arranging, our first actual question asks us to find the range. Now, this is just revision. We find our range by doing our largest number, so 96, minus our smallest number, 19, and that's going to give us 77. Just a bit of revision, not too bad so far. Now for part C, we want to find the middle, the median, so the number right in the middle here. Now, you can try to systematically cross off these numbers or count them, but since I've already done this question, you can pause and find the median for yourself, but this is going to be 73 because I have 1, 2, 3, 4, 5, 6 numbers on one side, 1, 2, 3, 4, 5, 6 numbers on the other side. So, if you remember when we looked at median in the past, our number, if we have an odd number of data sets, of data points in our set, we have one distinct median, a number kind of smack bang right in the middle with equal amounts of numbers on either side. So this is our quartile 2. So our median is 73. Okay, now we want to find second, the lower quartile. So now that we've found this middle number, we can see that we have split this into this is the lower end of my data, and this guy here is my higher end of the data. So that's what my median essentially does. Now we can see this. It splits up our data into two sections, a lower end and a higher end. Now we want to find, well, what's the middle of this entire lower end here? Well, looking at these data points, I have exactly 6. I have 19, 23, 56, 62, 67, 68. I want to find the median of these numbers. Now, feel free to pause the video if you want to revise finding the median. But I notice here I have an even number. So I have 2 medians here. And I want to find what's right in between those. So what I'm going to do is, we remember from previous statistics, we are going to, for my quartile 1, that's going to be a number right in between these two. Or in other words, our average of these two numbers. So to find our average, we're going to add them together and divide them by the number of numbers there are. So, whoops. Okay. Beautiful. Now, our quartile 1, therefore, is going to be 59. And we want to do the same thing for our upper end. We want to find the middle of the upper end. So I see once again, because this is split perfectly in the middle, I have 6 points here, 6 data points. So I want to find the average of the two middle ones here. So this is going to be my quartile 3, because remember, my quartile 3, my upper quartile, is the middle of my higher end. So Q3 is going to be the middle of these two numbers, 81 and 85. So we are going to average these out. And that is going to give us 83. And now that we have all of our values here, my interquartile range, which I have forgot to actually define for you guys, my apologies, my interquartile range we find, by taking our upper quartile, Q3, and subtracting our lower quartile, Q1. Very sorry for doing this late. Should have done it earlier, but now that we have all of these values, so I found my quartile 1 and my quartile 3. So my Q1 equals 59. Q3 equals to 83. My interquartile range is just a difference between my upper quartile and my lower quartile. And it's a type of range because we're seeing what the spread is between my middle of my lower section and the middle of my upper section. So, hence, why we do the same thing that we do with regular range. We are finding the difference between these two numbers. Now that gives us 83 minus 59, and that finally gives me 24 as my answer. So this is my interquartile range, and we find that by subtracting our lower quartile from my upper quartile. Now, let's try another question, and in this case, we have a set of measurements collected by measuring the lengths in meters of 10 long jump attempts. And this question has an even number of data points. And we're going to see how this changes our approach when finding the interquartile range. So, once again, I'm going to list the data in order from smallest to largest. So I have 5.1, 6.7, 7.1, 7.9, 8.2, 8.3, 8.4, 8.8. Shrink this. We have 9.0 and 9.2. Okay. Nice, we have all of our points here. Let's have a look at making our calculations now. So, we've got all of these are laid out here, and we are going to do the same thing that we did in the last question. Very similar approaches. So you can pause this video and have a go on your own, or you can work along with me. So the range, we know we get that from subtracting my smallest number from my largest number. And in doing that, I get 4.1. And now we can work through pretty much the main part of this video, which is calculating my median, lower quartile, upper quartile, and then interquartile range. So here, let's find our median first. Now we have an even number of terms here. So that means we're gonna have two medians here. So we get these two right in the middle because I have 4 terms on each side. So my median is going to fall right in between these two values. So our median, or Q2, we're going to get by averaging 8.2 and 8.3. And that's going to give us 8.25 meters. So now we're moving on to calculating the actual lower quartile and upper quartile. So if we look at how our data is arranged, the middle of my data falls right in between these numbers. So it's going to split these data terms into the lower half and these guys here into the upper half. So this is my lower half of my data split by our median, and this is my upper half of my data. And we can see that this is split equally because now I have 5 terms on the left and 5 terms on the right. So taking an average of these two terms gives me a number right in between. So that's why we're considering the 8.2 as part of the lower half, because that gives me 5 equal data points on the left, on the lower half, and then 8.3 falls in with the upper half to give me another equal number there. So once I get here, I can just locate my middle of my lower half and upper half, or in other words, the upper quartile and the lower quartile. So I have 5 terms here on the left hand side. So I have an odd number, which means I'm going to have 1 middle, and that's going to be this thing here. So this is going to be my quartile 1, and this middle term here is going to be my quartile 3. Now, what I'm going to do is to find my interquartile range, I'm going to subtract my first quartile from my third quartile, right? Well, my lower quartile from my upper quartile. So here I'm subtracting 7.1 from 8.8. Oops. And once we do this, that gives us 1.7 meters. Okay, nice. Now, let's just quickly consider what portion of my whole data the interquartile range takes up, because this is how we're going to start to interpret the interquartile range. Now, if we go way back up to the very first part of this video, the whole entire range that's spanned by quartile 1 and quartile 3 is this particular bit here. Now, how much of my total data is found inside the interquartile range? Well, I have the 25% from my lower and the 25% here between my median and my upper. So the IQR makes up 50% of my data. So first of all, let's just make a note of that. So my 1.7, this thing here makes up 50% of the data. And that essentially all we're asked to interpret, because we're not really going too deep in this so far, but we can just see here that the middle 50%, so these 50% of our data set values for this long jump, this 10 long jump attempts, these 10 long jump attempts, the middle of them differed by 1.7%. They actually differ, because 1.7% is the full spread from highest to lowest. So all these values in the middle differ by less than 10%. By less than, 1.7 meters. This makes up 50% of the data. And we can say here that our middle 50% of jumps differed by less than 50%. Sorry, I keep saying that. Differed by less than 1.7 meters. So this is how we can interpret our interquartile range, and it tells us really about the spread of the middle. So here, it's actually a relatively small spread when you consider the range. So a lot of the stuff seems like it's packed into the middle. And when we compare that with something like this, we had a pretty big range and also a bigger interquartile range. So essentially, the interquartile range, it communicates to us about what's happening in the middle portions of our data. If we go back to this diagram here, we are looking at the spread and difference between the middle of our bottom end and the middle of our upper end. But that brings us to the end of interquartile range. We will talk about this further in the next video when we start to talk about box plots. So I'll see you there, and thanks so much for joining me.